can we try to come up with an intuitive explanation for inverse sine, sometimes called arcsine, or inverse tangent? Yeah, absolutely. Let's go back to this same unit circle. The circle that, recall, if I am 1 unit away from the origin, is going to tell me the sine value or cosine value for any particular angle, just in terms of its x and y coordinates. For example, for an angle of pi over 3 in radians, which is the same as 60 degrees, the cosine of that angle is going to correspond to our x coordinate on the edge of this unit circle. The x coordinate there is 1/2, and that's why we say something like cosine of pi over 3 equals 1/2. The y coordinate is going to give us back the sine of that same angle. So this is why we would say sine of pi over 3 or sine of 60 degrees is equal to root 3 over 2. But what if I wanted to do this process backwards? What if I gave you a y coordinate? I said there's some angle that when we draw it into the unit circle, it's going to give us back a y coordinate of root 2 over 2. Essentially, we're saying the sine value of some angle is equal to root 2 over 2. What is the angle? We could write this that theta is equal to the inverse sine of root 2 over 2. Now, you might be able to tell in this case I chose a nice angle that works out to pi over 4 radians or 45 degrees, and so that's what our calculator would return to us. Theta here is equal to pi over 4. One thing you have to watch out for though, one thing you might notice here is, wait, isn't there another place on the unit circle where the y coordinate is also root 2 over 2? And the answer is yes, there is. In fact, with an angle of 3 pi over 4 or 135 degrees, when you take the sine, you would also get back that same root 2 over 2. And so what we have to do to compensate for that is called a domain restriction. If we're going to use this arcsine or inverse sine function, we need to make sure that we're only using it on a region of the unit circle where our y coordinates are unique, where none of them get used more than once. The way that we do that with the y coordinates is we use quadrants 1 and 4. And to make things nice, we count that from negative pi over 2 all the way up to positive pi over 2. So remember, angles can be negative. It just means that we're going to count them clockwise from the positive x-axis instead of counterclockwise. Similarly, if we wanted a function that took a given x coordinate and returned the angle on the unit circle that corresponded to that x coordinate, that is, if we wanted an inverse cosine or arc cosine, we would need to restrict ourselves to an area of the unit circle where our x coordinates don't get used more than once. And that area is quadrants 1 and 2, and that's why we only use the inverse cosine function to return angles between 0 degrees or 0 radians and 180 degrees or pi radians. For arctan, we need a place where the ratio between sine and cosine would be unique, and although there are multiple ways to do it, that turns out to be the same thing as restricting ourselves to negative pi over 2 to pi over 2 for arcsine.